President Donald Trump's recent announcement of a 10% tariff on Chinese imports, set to take effect on February 5, 2025, follows his earlier declaration to impose 25% tariffs on imports from Canada and Mexico. These measures are part of his administration's strategy to address issues such as illegal immigration and drug trafficking, particularly the influx of fentanyl into the United States. The Chinese government has emphasized the mutual disadvantages of a trade war, stating that there are no winners in tariff wars, and warning that such actions could harm all parties. The proposed 25% tariffs on Canada and Mexico have elicited strong reactions from both nations. Canadian Prime Minister Justin Trudeau has indicated that Canada will respond to these tariffs, emphasizing the country's critical energy resources needed by the US economy. Ontario Premier Doug Ford described the tariffs as a declaration of war, announcing retaliatory measures, including boycotting American-made alcohol and targeting products from Republican-held areas. In the automotive sector, companies like Volkswagen have expressed concerns about the potential economic impact of these tariffs. Volkswagen, which operates a significant manufacturing plant in Puebla, Mexico, warned that such tariffs would harm American consumers and the global automotive industry, advocating for free and fair trade. In response, China has discreetly increased its countermeasures in recent months, actions largely unnoticed by mainstream media. These steps include prohibiting the export of rare earth elements, vital for technology and defense production, to the United States. Furthermore, China has reduced its oil imports from the US and imposed tariffs exceeding 74.9% on specific American products, significantly escalating the ongoing trade dispute. The range of these tariffs has expanded to include imports from the European Union, Japan, and Taiwan, reflecting China's extensive strategic resistance to what it perceives as economic hostility. This video explores the specifics of these retaliatory measures and assesses their potential impacts. We delve into the background of these actions and their broad effects on the global economy, including the particular repercussions for the US, EU, and other major nations. We begin by examining the tariff actions enacted by the US, EU, Japan, and Taiwan against China, which have fueled these rising tensions. Beyond the recent 10% tariffs, the Biden administration announced significant tariff hikes on various Chinese imports to counter what it considers unfair trade practices. Key actions include dramatically increasing tariffs on Chinese-manufactured electric vehicles, EVs, which have risen from 25% to 100% since late 2024, resulting in total duties of 102.5%. This move aims to protect domestic manufacturers from aggressive pricing by Chinese EV makers benefiting from substantial government subsidies. To promote domestic battery production and reduce dependency on Chinese suppliers, the US has raised tariffs on lithium-ion EV batteries from 7.5% to 25%. This measure targets a critical cost component of electric vehicles and seeks to bolster the domestic clean energy sector. By developing local supply chains for essential materials like lithium, cobalt, and nickel, the semiconductor industry has also become a focal point in the trade tensions, with tariffs on Chinese semiconductors set to double from 25% to 50% by 2025. This measure aligns with broader initiatives, such as the CHIPS and Science Act, to encourage domestic production and address security concerns. Related to reliance on Chinese components, tariffs have also been imposed on medical products, including syringes and other personal protective equipment, further escalating trade tensions. Needles and certain types of personal protective equipment are set to rise significantly in tariffs. Duties on syringes and needles, previously tariff-free, will climb to 50% by 2024. Similarly, tariffs on certain respirators and face masks will increase from 0% to 25%. These measures, impacting approximately $18 billion worth of Chinese imports, underscore the US government's commitment to reducing reliance on foreign-made medical supplies. The COVID-19 pandemic highlighted vulnerabilities in the global supply chain for critical medical products, prompting efforts to enhance domestic manufacturing capacity in this sector. Renewable energy, solar cells, and critical minerals. The United States has also targeted the renewable energy sector as part of its tariff strategy. Tariffs on solar cells imported from China have doubled to 50%, aiming to support US clean energy businesses and foster the growth of domestic solar manufacturing. Additionally, tariffs on critical minerals, such as natural graphite and permanent magnets, are set to rise to 25% by 2026. These materials are essential for renewable energy technologies, including wind turbines and electric vehicle motors. By imposing these tariffs, the US seeks to strengthen domestic supply chains and reduce reliance on Chinese exports for clean energy advancements. The European Union, EU, has also taken steps against China's alleged unfair trade practices. Starting October 31, 2024, the EU implemented tariffs ranging from 7.8% to 35.3% on Chinese electric vehicles, in addition to the standard 10% car import duty, effectively raising the highest tariff to 45.3%. This followed an investigation into subsidies for Chinese EV manufacturers, which the EU found to be harming European producers. The EU also introduced anti-dumping tariffs on Chinese imports of the sweetener erythritol, with duties ranging from 34.4% to 233.3% in 2025. These actions aim to protect the EU's industries from unfairly low-priced Chinese imports and ensure fair trade practices. Although specific tariff implementations by Japan and Taiwan are less evident, both countries have pursued broader economic policy changes to counter China's rising economic influence. Japan has been enhancing its industrial policies and supply chain resilience, particularly in areas like semiconductors and critical minerals, to reduce reliance on Chinese imports. Taiwan, a key player in the global technology supply chain, especially in semiconductor manufacturing, is diversifying its economic partnerships to mitigate risks tied to China's economic strategies. China's response. China has imposed provisional anti-dumping tariffs on imports of polyacetyl copolymers, a specialized industrial plastic, from the United States, European Union, Japan, and Taiwan. These tariffs aim to safeguard Chinese domestic industries amid rising global trade tensions. US firms face the highest tariffs, ranging from 57.2% to 74.9%, reflecting China's view that American companies are engaging in significant dumping practices. This makes it extremely difficult for US exporters, such as DuPont and Celanese Corporation, to remain competitive in the Chinese market. These companies traditionally supply high-performance materials for key industries, including automotive and consumer electronics manufacturing in China. Such high tariffs are likely to push US exporters out of the Chinese market, forcing Chinese importers to seek alternative suppliers or rely more on domestic production. In contrast, EU exporters will face a consistent tariff rate of 42%, a substantial but less prohibitive barrier compared to US companies. This indicates that while dumping by EU firms was identified, the overall impact on the Chinese market was deemed less severe, leading European producers such as BASF and Tian GmbH, a Celanese subsidiary, are major suppliers of polyacetyl copolymers to China, serving industries requiring high-performance materials. Materials like precision manufacturing for automotive and industrial machinery face challenges with recent tariff changes. The 42% tariff imposed on EU exporters will significantly increase costs, reducing their competitiveness in the Chinese market. However, due to their established reputations and high-quality products, EU firms may still find limited opportunities in specific high-value market segments. Japanese exporters face a slightly higher tariff rate of 43.7%, reflecting their competitive pricing and strong market presence in China. Japan's proximity to China and robust trade ties have historically made it a key supplier of engineering plastics, including polyacetyl copolymers. Companies such as Mitsubishi Engineering Plastics and Polyplastics Company Limited, specializing in high-performance materials for automotive, medical, and electronic uses, are significant players in this sector. The new tariffs are expected to disrupt established supply chains, particularly in automotive manufacturing, where Japanese materials are widely used for components like gears and fuel system parts. Nevertheless, Japanese firms' focus on innovation and specialized applications may help retain some market share despite higher costs. Taiwanese exporters, on the other hand, face the lowest tariff rate among affected regions, set at 32.6%. This suggests the Chinese government found less evidence of aggressive pricing or market penetration by Taiwanese firms compared to those from the US, EU, and Japan. Taiwan's strong petrochemical and plastics industry, led by companies like Formosa Plastics Group and Changchun Plastics Company Limited, produces essential materials for electronics and industrial machinery. While tariffs will increase costs for Taiwanese exporters, the relatively lower rate may enable them to maintain a portion of their market share, especially for niche applications or price-sensitive buyers. Polyacetyl copolymers, also known as polyoxymethylene, POM, are high-performance engineering thermoplastics valued for their mechanical properties, including high strength, rigidity, and thermal resistance. These characteristics make POM an ideal alternative to metals like copper, aluminum, and zinc, offering manufacturers cost-effective and performance-enhancing solutions across various industries. In the automotive sector, POM's low friction, coefficient, and excellent wear resistance make it suitable for components such as gears, bearings, and fuel system parts. Its dimensional stability under thermal stress and mechanical load enhances vehicle reliability and performance. POM's resistance to fuels and lubricants also makes it ideal for under-the-hood applications. In electronics, POM's electrical, insulating properties and dimensional stability in varying environmental conditions make it valuable for manufacturing connectors, switches, and housings for consumer electronics. Its low moisture absorption ensures consistent performance in humid environments, maintaining the reliability of electronic devices. In medical technology, POM is ideal for mission-critical components due to its high strength, stiffness, toughness, and lubricity across various temperatures and chemical environments. Its low extractables, high purity, FDA compliance, and being animal and latex-free make it suitable for medical applications such as dry powder inhalers, insulin syringes, and electric toothbrushes. For industrial applications, POM's mechanical, strength, low friction, and chemical resistance make it suitable for durable, reliable materials in pump components, valve parts, and conveyor belts. Its ability to withstand chemical exposure without degrading ensures longevity and reduces maintenance needs in industrial machinery. China's recent implementation of provisional anti-dumping duties on polyacetyl copolymers, with rates ranging from 3.8% to 74.9%, is set to significantly alter the country's market for these materials. Between January and November 2024, China imported approximately $3 billion worth of polyacetyl copolymers,